Let's complete our tracing review trilogy with at least one example that actually uses something new. So here it's going to be this one line, the auto keyword. Otherwise, it'll be another rehash of all of those scope tracing things that maybe now are flooding back to you from 111. So we'll just get started. So in this case, there are no global variables, so we can just start by making up our scoping box for main. And mercifully, there's no output statements in the function, so this time I actually get to make a nice big box for main and hopefully fit everything into one screen. Okay, so let's see. I start on line number 13, and as usual, I make myself some variables x and y. There's x, and its value is 111. And then there's y, and its value is 116. And then on line 15, I hit the auto keyword. So on line 15, I am creating a new variable z. And the value of z, the initial value of z, is going to be this thing. It's going to be the result of calling a function and taking the return value. There's a couple of things we can observe here. So one of them is, of course, that the type of z is not going to be this because this is not a type. The auto keyword is a clever way of having the compiler help you out figuring out the type of z, but the auto keyword is not the type of z itself. One thing worth observing is, in fact, that you don't need to actually call the function or even run the program to know what the type of z is going to be. The compiler was able to figure out the type of z when the code got compiled, before it ran. So it turns out that we actually know in advance what the type of z is going to be without calling the function f. Now that said, you're welcome to simply run the function call and then work out the type once you're done, but in this case, I'm going to work out the type before I call the function. So the type of z is going to be whatever the type of this expression is. So this expression is the result of calling a function. It's going to be this function. And notice how this function returns an int. So that means the type of z is going to be the type of that return value, which is int. So the auto keyword was certainly helpful for that. I didn't have to worry about figuring out the return type of f. But when I trace the code, I can work out the type of z without actually having to run the code, without actually having to call f. So z is going to be an int. It's going to be an int forever. For the entire lifespan of the variable, it will be an int. Okay, but I guess I need its value too. So there's my function call. I have to execute that to figure out the initial value of z. So f of xy, well, in this case, the value of x is 111, and the value of y is 116. So I'm going to add f to my diagram. There we go. And f comes in with two arguments. Of course, they're called x and y. And we'll notice, so 111 got assigned to x, 116 got assigned to y. So there's 111 and there's 116. And now I'm ready to begin executing f. So I've got all my variables for f set up. And so I can begin executing f on line number 2. On line number 2, we see a hallmark of tracing questions designed to verify that you know the second law of assignment statements. It says x equals 10. Well, in the scope for f, x and y are these two things. So x is now set to be equal to 10. Y is going to be set to be equal to 6. And what the trap that we're setting here is, in case you're doing this in your head, you might think that these pair of variables are the ones you want to modify, but of course they aren't. You want to modify the ones in the scope of f. So I set x to be 10, y to be 6, and I return the value x plus y. So x is 10, y is 6. That means that what I'm returning is the value 16. And so what I'm going to do is I'm just going to write that in here to make a note of the return value, and then the function f is going to end. So f ends, so I destroy its scope. There we go. We'll just delete that whole thing. And it is now gone, and I then come back to where I left off in main, where I was setting the initial value of z. I already worked out that f returns an int, and therefore the type of z is going to be int, and the value is going to be 16. And now I'm ready to print out some output. So I print out begin. And then I print out the value of x, and of course I'm in the scope of main here, so I print out the value of x, it's 111, the value of y is 116, and the value of z is just 16. And then I get down to line 17, which is another assignment statement, an assignment statement involving z, and I'm going to call the function g. So I'm going to add g to my diagram. And g takes two parameters. They're going to be called a and b, and they are both ints. And we have to be careful to keep that in mind, because we'll notice that what I'm passing in isn't an int. But I'm allowed to do this because we know that when I pass arguments into functions that are taking their parameters by value, which this one is, that I'm doing an assignment statement. And just like I would be allowed to write int a equals 2.5, I am allowed to pass in 2.5 as an argument to a function that takes a parameter of type int. And when I do that, what we end up with is we take the value 2.5 and coerce it into being an int, which means convert it to an int by, in this case, chopping off everything after the decimal point. So when I'm calling the function g and passing in the argument 2.5, 2.5, I assign those to ints. And that means that what ends up getting passed in are the number 2. The value of a when I start the function g is going to be 2, and so is the value of b. So I've done that. I've set up the arguments of g. I'm now ready. I guess I should have crossed off the left-hand side of this assignment while I get going here. I'm now ready to run the function g, so I head up to line number 7, where I am returning a plus b. Okay, so I return a plus b. Obviously, a is 2 and b is 2. So I return 2 plus 2. That is going to be equal to 4. I return the value 4, so I'll make a note of that by subbing in 4 for this statement here. And then g is ready to end, so I destroy its scope. It is gone. There we go. And then I can return back to main, and I can finish the assignment statement that I was running on line 17. So on line 17, I write z equals 4. And so that means I'm assigning the int 4 to z. Z is an int. Now, one thing that's worth, a sort of an interesting point worth noting here is, suppose that the value 4.5 had come back from g. It doesn't matter. It would still end up setting z to 4 because z is still an int. Just because z was declared using the auto keyword doesn't mean the type of z can ever change. And so the type of z was int when it was created, and it's going to be int forever. So no matter what came back from g, what ends up stored into z is going to be an int. Now it turns out, though, it was sort of a double negative because it turns out g sent back a whole number anyway. What g sent back was of type float, but it was a whole number. It was the number 4. So I set z to equal 4. And then I continue to line 18. On line 18, I ask the question, is z equal to 4? And the answer is, of course, yes. So I enter the if statement. I enter a brand new scope for this if statement. So I'm going to draw a nested scoping box. I don't know why I put this, why main in so, here we go, we'll give main some more space there. I make a new scoping box for my if statement on line number 18. And the very first thing that happens in my new nested scope is I create a variable called x, which of course, as we've seen from the past 2 videos, I am allowed to do, and I set its value to 0. And then on line number 20, I say x equals 200. Well, in the context of my current scope, this one here, x equals 200 modifies this variable to be 200. And then I see y equals 1,000. Okay, so in this scope, there is no name y, so I go looking outside in the outer scope, and there I have this. So when I use the name y on line 21, I'm actually referring to this variable here. So I set this to equal 1,000. And then I declare a new variable called z, which of course we know by now I am allowed to do. This z, the one inside the if statement, happens to be of type float. And it's going to get set to the result of this assignment. It's going to be set to it. I'm going to set it using this assignment. I'm going to set it the result of this function call, h of x, y. I'm going to cross off the left-hand side while I work on that. So the value of x in this scope here is 200. So x gets subbed in for 200. The value of y in this scope is 1,000. So I'm going to call h with those 2 arguments. So I guess I better add h to my diagram. There's h. H takes 2 arguments. They're called a and b. And the value I'm passing in as a is going to be 200. Just 200. And the value I'm passing in as b is going to be 1,000. So I've got the arguments set up for h. I'm ready to actually start executing h. And the very first thing that happens is I return a over b. So a over b here would be, let's see. So I know the values of a and b. That's 200 and 1,000. And I can observe that, okay, both a and b are of type float, which means that what I actually get out of here is 0.2. What I should notice, though, is that the return type of h is int. So whatever gets sent back from h must be an int. No matter what I'm going to end up doing with it, it must be an int. And that means what I send back has to be 0. because of course we know how we coerce a float into an int, we just chop off the decimal point. So instead of 0.2, the return value I'm sending back is going to be 0. So I'm going to replace my call to h with its return value. It is 0. And I'll clean this up. And of course, I've got the return value noted, so I can now end my function h, and I'm going to do that. There we go. We'll just get rid of its scope. We'll erase all this stuff. And when I come back to main on line 22, I can uncover the left-hand side of this assignment and know, oh, that's right, I'm assigning 0 to my variable z. Great, 0. If I wasn't careful, if I happen to remember a bit too much about z, for example, that z is a float, and I think, wow, I had that 0.2 up here. I really want z to contain 0.2. Then I could make some kind of mistake, because obviously the compiler doesn't think about the world that way. The compiler does one operation at a time. And so in this case, yes, I have to convert that float to an int, and then sure, I store the int back into a float, but the damage is done. It's already 0. Now, strangely, for this particular example, it's actually a moot point because there is no output here that prints out the value of z. So on an exam question, I probably would have put an extra print statement like right here or something to make sure we got that part, but I didn't. So that means on line 23, I obliterate the if statement and all of its contents, all the contents of that scope. So on line 22, so I just delete this, everything inside of here. So although we did have the correct value of x and z inside that scope, we never actually printed them out. Although if on an exam question, you might not be so lucky. You might be expected to print something out inside the if statement. And that brings us to line 24, where I print out end. And then I dump out the variables that are in main. So in this case, I've got x is 111, y is 1000, and z, in the context that I have it, is 4, the integer 4. And so I use the auto keyword there. It didn't get, I mean, not to great effect, but the two things to observe are, first, the type of z is determined by its initializer here, and it's permanent. So z was assigned as its initial value an int, which made z an int forever. Down here, I tried to assign something to z that happened to have type float, but that doesn't change the type of z. The type of z is still going to be int, because once the variable is created, its type is permanent.